So in this video, we'll briefly explore how to use substitution methods to decrease the amount of work for integration by parts and what happens when we have limits on our integrals. So here we have the integral of theta cubed cosine theta squared. Now initially it looks like this is going to be a bit complicated, maybe several rounds of integration by parts and whatnot. But we can make a substitution that will help us solve this rather quickly. Okay? So what I'm going to do is I'm going to set x equal to theta squared. Okay? If x is equal to theta squared, okay, then dx d theta is equal to 2 theta, and dx is equal to 2 theta d theta. All right. That may not be obvious what I'm about to do, all right, but now I want to take that and I'm going to make a substitution to my function. Okay? So if I rewrite this, integral theta squared cosine theta squared times theta d theta. Okay, now notice I've got theta d theta and theta d theta. So I can make a substitution where I substitute x values for theta squared and dx over 2, right? I have to divide both sides by 2 to do a theta d theta substitution. So after I do my substitution, I'm going to have the integral of x cosine x times 1/2 dx. Now I can do an integration integration by parts. Okay, so I'm going to focus in on cosine x sine x. Okay. So now if I set u as x and dv, okay, as 1/2, I'm going to ignore the 1/2 and I'm going to transform it out to the front and get rid of it in here, because okay, we don't need it. So dv is now cosine x dx. Okay. Now du is always u prime dx, so in this case we're just going to be 1 dx. And dv, well, I need to take the integral of cosine x. So the integral of cosine x is simply sine x. Now I substitute my integral. X cosine x dx, right, u dv, is equal to u times v, x sine x, minus the integral of v du, integral sine x dx. Well, now I can finish this off, x sine x minus, okay, which is going to become, integral sine x is going to become an opposite of cosine x, so that's going to be plus cosine x plus c. Okay? Now all I have left to do is substitute my value for x back in. All right? So if we forget, all right, x we said was theta squared. Okay? So now we've got theta squared sine theta squared plus cosine theta squared plus c. And there we are. Just like that. Alright, so you see a nice simple substitution. Alright, it's made a seemingly complicated problem a little bit easier. Okay, well, that's one case. Alright, take a nice look at that. Okay, you want to grab a screenshot or whatnot. All right, now what happens when we have limits on our integral? I'm just going to add a new page. I'm going to draw an integral. Okay, now what happens, let's see if I have the integral. Let's try to use one that we're comfortable with. How about the natural log of x dx? And let's look at that over the range of 1 to 2. Okay, so now we have the natural log of x and we have limits. Well, you may remember that we need to solve natural log of x, we have to do this through u substitution, right? So we used u as the natural log of x and dv as dx. Okay? So that gave us du 1 over 1 plus, 1 over x, and v is equal to x. Okay. Now we need to fill in our integral. Right? So the integral from 1 to 2 of the natural log of x dx is equal to u times v, natural log of x times x. Now here's where the first difference comes, right? We need to evaluate our uv on our limits, 1 to 2. And then integral 1 to 2 of integral of v du. All right, so now we're looking at the integral of x over x dx. Okay. So if we look at what this is going to become, this is going to be the natural log of 1 times 1 minus the natural log of 2 times 2. Oops, I have those backwards. My apologies. Natural log of 2 times 2. Now if we take away the natural log of 1 times 1, all right, let's remember division of natural logs is, subtraction of natural logs is division. So if we take the natural log of 2 minus the natural log of 1, that's like saying the natural log of 2 divided by 1. Right, so we leave that as natural log 2. Okay. And we take the integral away. Now we note these are going to cancel to become 1. And we're going to be looking at the integral of x dx. Right, so we evaluate x at 1 and 2. And we're going to be looking at 2 natural log of 2 minus 2 minus 1, right? B minus A. So 2 natural log 2 minus 1. And there you go. So the only difference, really, when it comes, when we start dealing with definite integrals and integration by parts, right, is that we can't forget we need to evaluate the uv at our limits.